Welcome back to Chemical Safety at Work, the podcast. Mel and I have flown up to Melbourne today to meet with Ryan Hammond, Director of Sealed Performance Batteries and Electrical Engineer. Ryan, can you tell us a little bit about your area of expertise and how you ended up working in this field?
Yeah, so I'm an electrical engineer by trade. Started out my journey at Siemens as an automation engineer, so did a lot of tech support and product management. And then went into worked for NHP, which is an electrical wholesaler in Australia, privately owned electrical wholesaler. They do a lot of importing and distribution of electrical engineering products. And that's where I met my two business partners there and worked in the electrical industry mainly, but it was the distribution side of the business that was very interesting for us.
Yep.
My business partner, Greg, he sort of did the deal with Sealed Performance Batteries 2014. He purchased the business.
Yep.
And again, it was the distribution side, and I was lucky enough to be offered to come on board as a shareholder and a director for my technical knowledge. So worked with Greg for 7 years at NHP. And we saw very early at that point in time, it was mainly an automotive business, automotive battery business, with a little bit into sort of energy storage, UPS, fire and security, but it was just battery related, importing and distribution. And around about that time, Lithium-Ion was a flavour of the battery industry, and we saw an opportunity, given my electrical background, to go and have a look at what was out there and try and actually bring some of these products into Australia and introduce Sealed Performance Batteries into those new and emerging markets.
That's great.
Yeah, nice.
So what does Sealed Performance Batteries do? And tell us a little bit about the business.
Yep, so we're professionals in energy storage, and essentially we import batteries from all around the world, really, and then sales, market, technical support those into the Australian market.
Excellent.
And we cover off on a whole range of industries. So a large part of the business is automotive batteries, so car, truck, marine, starter batteries, if you like. And that was traditionally what Sealed Performance Batteries was mainly focused on before we sort of took it over. But now we've expanded that into other areas such as energy storage, as I said, UPS, fire and security. We also do a lot in electric vehicle charging as well, battery monitoring systems, do inverters for residential energy storage as well. So we've expanded the business from just pure energy storage, but that's still our core business as professionals in energy storage.
Sure. Would we recognise any of the brands that you supply to?
Yes, so in the automotive space, Energizer is probably one of the most well-known brands, not so much in the automotive, but that is starting to become more and more prevalent. AC Dalco is another one in the automotive space.
Yep.
And then our own lithium brand is Victor.
Okay.
Victor Lithium is probably is quite a well-known brand in the space as well.
Yeah, for sure.
That's great. So what are some key factors that set high-quality lithium batteries apart from cheaper alternatives on the market?
I'd say probably the cell quality and the BMS quality are probably the two main items. From there, it's then the construction of the lithium batteries themselves, and then testing and certification. The challenge you've got on cell quality and BMS quality is actually how do you tell? And that's always the biggest challenge. I think most reputable businesses know that there are sort of three key cell quality that comes out of a lot of the factories in China. There's a cell, a B, and then a C, which is generally a reused or repurposed cell.
Yeah, okay. Yep.
A being the highest quality, the cell, and B being one that's sort of rejected as the A type. Still new, but rejected as the A type.
Sure.
And unfortunately, cost isn't always associated with quality, although it is a good indicator.
Yep.
It's a fair indicator in this space, but not always. But again, those things are very hard to tell in the lithium-ion battery.
Can you explain BMS to us?
Yep. So BMS is a battery management system.
Yep.
also called PCB. It's a small protection device in 12 volt and 24 volt, 36, less so 48 volts. They should all have a BMS in order to protect the cells against misuse. So apart from the ones that are going into a sort of an energy storage system, like a 48 volt residential energy storage or a large one, the BMS in 12 volt or 24 volt in one of those, lead acid replacement style is actually called a protection circuit monitoring. It's a PCM is a technical term for it, but it doesn't do a charge management. It's a protection device. So it just protects if there's an over voltage, it protects the open voltage, opens a MOSFET, puts into a short circuit. Over temperature, it'll stop the charge or discharge.
Yep.
So it's really just a protection device there to protect the cells from misuse.
Yeah, sure. So pretty crucial. And then obviously not knowing the quality of the BMS and the cells is where testing becomes so important. Can you just walk us through the testing process that batteries undergo to meet industry standards?
Unfortunately, there really are no minimum mandatory standards required for bringing in lithium batteries. And as a result, we do see a lot of low-cost, low-quality batteries coming in. Essentially, anyone can buy anything and bring them in. We're starting to see a few of the industry bodies introduce standards in their sector. The caravan industry has tried to implement a requirement around IEC standard. The Clean Energy Council also has some requirements around their battery certifications. We're seeing in the marine sector as well starting to request the requirement for the batteries to have a certain level of certification.
Yep. So you basically set the standards for yourselves at this point?
Yeah, we did, and we did that early on. Being an owner of the business, we have to be able to sleep at night.
Yeah.
So we wanted to make sure that the products that we were bringing in were of the highest quality and as safe as reasonably possible.
So how do you ensure that?
So we did it right from the start, as well as, so one of the things we did do, we went and visited, I think, 6 or 8 lithium, these are lithium iron phosphate specifically, manufacturers back in 2015, 2016.
Okay.
We actually went and visited the factories and saw how they were being manufactured, saw the quality, saw how they would do the testing at the factory level themselves. We selected a factory that we worked with that manufactured their own cells, designed and manufactured their own BMS, and then did their own assembly, which for us was quite important because we had our own requirements for the BMS, and so that's one of the things that we had. That was our own IP. But I think we mentioned down the track about the certification and how we then ensure that once a battery's certified, how you can't then swap lower cost cells out or lower cost BMSs, which is actually a very good question. And there are many factories in China that buy a cell from a cell manufacturer, buy a BMS from a BMS manufacturer, assemble them, and then sell them as their own product. And those particular manufacturers, it's quite common for them to say, okay, well, that particular cell manufacturer's now got more expensive than we want, and so the next batch will use this cell. And again, as I was saying before, unless you cut the battery open and have a look at exactly what's inside it, that's very difficult to tell from shipment to shipment.
Yeah.
And so with the Invicta range, especially with the factory manufactures the cell, the BMS, and also does the assembly, so they won't be swapping cells out or BMSs out. And 2017, 2018 was when we first requested a IEC 62619 certification, which is an industrial standard, international safety standard for lithium batteries for industrial applications.
Okay,
And we requested that at a battery level, so that it doesn't only require the cell to be tested, but it requires the BMS and battery system to be tested as a complete unit for safety. And that particular one also required the factory was audited once a year. Well.
So,
That's good.
So that was, and we've sort of we've done that early days, and was something that we promoted, and we're really one of the first to the market in that 12-volt space and 24-volt space. It was ISE 62619 at a battery level was quite common in energy storage systems, so residential energy storage systems.
Okay.
But the difference there is that those applications are in a house, normally in a
very different
garage.
application.
They're matched to an inverter, which is the charger.
Yep.
Quite often they communicate with the charger and they don't go anywhere.
Yep.
Whereas with the 12-volt range that are a lead-acid swap out, there was very little control of the application that once we sold it, they would go into caravans, boats, whatever. And so we were very conscious of that safety aspect.
Good.
For sure. So what are some of the actual physical tests that you undertake?
So the ISE certification is done in an independent approved lab. There's generally an impact test or a puncture test. There's a temperature test. There's a crush test, short circuit test. And there's a couple of different ways. There's two most of the common standards that lithium-ion is tested. There's a 62133, which is for portable applications, and that's generally done at a cell level. So the cell's tested, so it's crushed, it's punctured, short-circuited, it's dropped, it's put in an oven for temperature, and it needs to not catch fire, essentially. There's a few requirements, but essentially the cell itself can withstand those testing elements and not catch fire or
Sure.
That's good. And does that have to be done frequently as well, or volume-wise?
No, generally it's done on a cell by a part number,
Yep.
and then you get either a test report or even better is a test certificate which certifies that the test report is done by an independent test house and that they passed based on the correct parameters. And then as long as you're using that part number and that same cell over and over again with no modifications, then that's considered certified. So the difference between the 62133 and 62619, 62619 can be done at a cell level as well. So one's portable applications, one is industrial, is that the 62619 also has a BMS component tested. So as well as doing on a complete battery system, you do a drop test, you do a crush test, do a short circuit test. It also has an overvoltage test. So if you've got an overvoltage across the terminals, does the BMS do what it's supposed to do, which is protect? There's an over temperature on the BMS, and there's a discharge test as well. And there's also a cell-to-cell short circuit. So if you've got a pack of cells, what happens if one short circuit? The propagation of short circuits. And so sort of that next level up that you can always have a cell tested, but it's a completely different beast when it's put with other cells and then a BMS on top and then is charged and discharged. So, they're probably the two main ones that are floating around and are now becoming more and more prevalent and asked for more and more often.
So given that you're doing all of that testing by choice, essentially, it's fair to say that not all testing is done equally across all brands and all sources.
No, that's right. I think most reputable dealers these days will work with batteries that have at least a cell level certification. And I think that's being from the manufacturing level is seeing as more and more of a requirement than it was sort of when we first started 8 years ago. So the 62133 at the cell level and even 62619 at a cell level is not uncommon these days. There's still some out there that don't, but it's not uncommon. 62619 at a cell level again is not as uncommon as it used to be. You couldn't get it, but it's still quite rare, relatively rare at a battery system level, and that's really because of the cost. So it's not again, going back to before, the battery is tested at a part number. So every part number has to be certified. So, you've got, and by the way, we still have our whole range 62619 certified because it's, we've we've got 60, 70 batteries in the range.
Yep.
And so we've got a large portion of them, but that is expensive to do.
Yeah.
But even as simple as, well, we've got a 120 amp hour battery certified and tested, which uses exactly the same cells and same BMS. At a 100,
source,
you've just got one less series of cells.
Yep.
They can be argued that,
it's pretty safe.
It's pretty safe.
Yeah.
Yep.
But some aren't tested at all.
So what would you say, Ryan, are the common dangers associated with improperly stored batteries, particularly automotive and industrial settings?
Yeah, the storage of the batteries themselves, especially new batteries, we find is relatively safe.
Yep.
Lithium-ion batteries should all have as a minimum, a UN 38.3 certification as well, which is a transport, and that does test a lot of the environmental aspects, heat, vibration, temperature, crushing, that sort of stuff. It does test that the batteries perform in a safe manner, not under use, but during travel. So, again, not all batteries have that certification. They should, but but there's not all have them. So the storage of new is quite safe.
Yep.
They're generally packed well and isolated from all the other ones. So automotive side, it really just comes down to your dangerous goods code. If you've got a certain amount of automotive batteries, they're a flooded battery, so they have an acid content, and that then comes under a DG code for storage.
Yep.
But again, they're sort of relatively safe as they are new, sitting on the shelf. The challenges we see more so with the lithium than automotive. Automotive, you can come back leaking batteries and stuff, but it's not the end of the world. You can clear it.
And people are probably more aware of it these
Correct.
days as well.
Yeah, and there's something you can see physically if it's leaking. We see more of an issue with used lithium batteries that, the BMS may have been damaged and is not working. You don't know how they have been treated. We've never had an issue, touch wood, but used lithium batteries coming back. They're a little bit more careful on those, and we tend to store them in a cabinet if you can, tape the terminals up, and we go through a little bit more in-depth procedure when we're storing the used lithium batteries until we get them picked up for recycling.
Sure.
That's good.
What are some of the biggest challenges with maintaining a battery supply chain?
I think at the moment, freight,
Yep.
especially with lithium, for all of the issues that are in the press, and they're generally related to a different type of lithium chemistry than lithium-ion phosphate is what we sell. So, the e-scooters and e-bikes don't use lithium-ion phosphate generally. They use a lithium polymer.
Okay.
Right.
And so it's a more dangerous lithium than a lithium-ion phosphate.
Is there a reason behind why they use that type?
Because of the energy density. So you can fit more capacity into a smaller. So electric vehicles, for example, that was quite common, NMC and NCA type lithium, because you could fit a lot more energy into a smaller space, essentially.
Yeah.
But they've got a lower thermal runaway point, and so they are seen as more dangerous. And we've actually seen the movement away from those lithium technologies, even in EVs to a certain degree, especially in residential energy storage. So when they first came out, the likes of LG Chem had an NMC technology, I believe. They're sort of, and so did Tesla, they're sort of now moved towards a lithium-ion phosphate as well. Yeah, so there are certain aspects of the supply chain, and I think freight is, as I said, freight is one of them. It's very difficult even for us to export, even to New Zealand, to get a couple of lithium batteries on a ship to New Zealand. I'm sure a few hoops. But even with all of the paperwork, so that's probably at the moment the highest cost and pain in the neck thing, really. Is the freight.
And I imagine that's different between the type of freight, so air freight, sea freight.
Yeah, well, no one will take lithium on air.
Too dangerous.
It's all sea freight.
Yep.
and it's all good, well and good when you're doing full containers. Everything's like that, but putting lithium in with a mixed container introduces other challenges.
Yep.
Aside from that, everything it's got the normal supply chain issues.
Yep. Any business.
Yeah, any business. Yeah.
That's good. And I guess expanding on that, what role does battery technology play in advancing the automotive industry?
It's an interesting question, and I sort of had to think about it. I'm not sure which one came first.
Yep.
I know that the increase of lithium-ion technologies certainly has helped in the expansion of electric vehicles. So you went from lead acid, which was heavy for its capacity, slow to recharge, and it's had all of the issues with lead acid, to then lithium coming on and gaining more awareness and traction, and that. Yes, I don't know which one came first. I don't know whether the automotive industry was pushing the battery industry or the battery industry was working with them, but that has certainly sped up the development of a lithium-ion, and therefore also the increase in electric vehicles, because they've then got a battery technology which is usable, as opposed to really the lead acid, not so much. But we also see the automotive space pushes a lot of the technology on batteries, like in the 48 volt area, for example. They moved to a 48 volt platform. So I think there's probably a bit of on each side of the fence.
Back and forth.
Yeah, which ones are dragging, which ones are into the newer technologies and the requirements for what the newer technologies are.
That's good.
But, there's probably a bit on both sides of the fence there.
Yeah. Well, there must be massive investment in battery technology research now with just how rapidly EVs are being adopted now, wanting to see
further mileage.
Increased
mileage. Yeah. And I think it is, and you'll see the increase in demand that the electric vehicle sector has had on lithium has meant there's a massive increase in the number of factories that are now making lithium in China. I mean, when we first went over there in 2015, there would have been 6 or 8 major factories, and everybody knew them. They're still there. The large ones, Cattle, Vision. There's a few more, that BYD. But now, if you go, there's hundreds of them.
Wow.
There are, and a lot of those lead acid battery manufacturers moved into lithium, and there was a lot of new lithium manufacturers pop up because of the amount of, I assume, probably government assistance that was available, and just the demand that the increase in electric vehicle sales created.
Yep. From a consumer's point of view, how do they determine, or what should they look into to determine what is going to be a good quality battery? How do they know, other than just having to trust the supplier?
Yeah, so actually, that's a good question. I sat on the board of the Australian Battery Industry Association up until very recently, and one of the things that we put out was a consumer's buy guide for lithium batteries. So just some simple things to look out for, and ask the question of your factory or who you're buying the batteries of. We started with certification, so and that can be ISC test certificate 62133 or 62619. At least ask the question: have you got a test certificate? Have you got a test report? A UN 38.3 test certificate or test report? Do you know what's in it? What type of cells they're using? What type of BMS they're using? So it was really just a list of things to ask questions about.
Yep.
And if they can't answer the questions, or they can't produce, then the battery might be fine, but they actually don't really know whether it is or it isn't.
Yep.
So it's probably best to
avoid the risk.
One that does have all of that information and that can answer the questions that you're asking.
Yep.
So that document is available on the ABIA, so Australian Battery Industry Association website for their members.
Okay.
It's a free download that was produced at a board level for the members to utilise, because that question came up a lot.
Yeah.
About, well, how do you tell?
And,
you can. There's For importers or resellers, so not talking consumers here, simple as taking a lid off one.
Yeah.
Yep.
And then having a look, is it packed correctly?
Yep.
The assembly, as well as the cells and the BMS, as I've said before, the assembly of inside the case of the lithium can tell a lot about the quality.
Yeah.
So are they just because generally the actual pack itself is quite a bit smaller than the case.
Okay.
Because they'll use standard case sizes.
Yep.
And you can take the lid off, and quite often they're just packed with foam.
Okay.
It's just shoved in there, and they fill the gaps with some packing foam.
Right.
Okay.
And it moves around. You can shake it, and so simple as that. The cable, the gauge of the cables from your terminals, does the gauge match the rating on the current rating? So if it says it's allowed to pull 100 amps. Does the gauge of the thickness of the cables actually match the fact that it can do 100 amps?
Yep.
Is there a temperature? The BMS has got a temperature protection in there. Is there a temperature sensor sitting there? So those sorts of things can all be told. You can see it very easily. You can't tell what type of cell it is. That's very difficult.
Yep.
Or the quality of the BMS to a certain degree. But the construction, if you take a lid off, and you need to be obviously qualified. I'm certainly not recommending any consumer take the lid off their lithium-ion battery. But, if you're qualified and capable of doing it, then taking the lid off and having a look
Doing an
at what's
inspection.
inside is a really good way of getting an idea of the quality.
Yeah.
And for us, we have samples of our batteries that you can take the guts out.
Yep.
That's something that we're happy to show.
Yep.
And I think, again, most reputable dealers are happy to show you.
Yeah.
what's
Be
in there.
transparent with that.
Yeah.
For your average end user, consumer, say someone who's just wants to buy an e-scooter for their personal use, who probably isn't going to go do all that due diligence on their battery, it's a little bit more tricky.
It is, and especially with the e-scooters because it is a different lithium chemistry.
Yep.
What I would say, and I'm by far not an expert in that space, but what I would say in that is to buy from a reputable dealer and to also have a matched charge with those ones.
Yep.
Yeah, great.
Quite often they can be charged from a charge you've got lying around, which is not always matched to the battery technology.
That's interesting. Do you have any tips on how consumers should look after their batteries or get more out of their batteries?
For our 12-volt ones, again, I won't talk scooters or e-bikes because it's not in our sort of wheelhouse. But for ours, they're a lithium battery, so you should treat them. They're full of electronics as well, so they've got a PCB in them. So wherever possible, store them in a reasonable temperature. Avoid heavy contact from them. Having said that, the batteries, the good quality batteries, are designed to be installed in caravans on the outside of the caravans and take a beating.
Yep.
But just monitor them and make sure that you are getting, a lot of them have Bluetooth these days, so you can tell if they're getting fully charged and fully discharged, and the temperature is within reasonable windows.
Yep.
So those sorts of things. If we get one back, we'll always check that. We'll do a full charge and make sure that it protects at the top of the charge. We'll do a full discharge, make sure the BMS protects at the bottom of the charge when it does. You can then test the capacity, so how much capacity is remaining, and then we'll do things like a short circuit test. Okay, so is the BMS actually working as it should?
Yeah.
Yep.
And again, I don't recommend our consumers do that, but there are businesses that will do a quick check for you, and
great.
something that they should be doing. If you send a battery back for warranty, that's normally what the supplier will do.
So how do you see the future of battery technology evolving, particularly in terms of sustainability and performance?
I think we spoke about this a little bit before. There's, especially with the increase in lithium battery technology, there was nothing happening in battery technology for, I don't know, probably 20 or 30 years, really.
Yep.
Lead acid was it.
Yep.
and then Lithium-Ion came on board, and then we've seen there's new technologies coming in that we hear about on a, probably a monthly basis.
Wow.
It's just something new comes up, pops up, and we have a look at it. And even over the time that we started with lithium-ion phosphate, from there we've seen sort of aqueous energy, which is a saltwater battery, come and go. There's an EcoFlow, which is a flow battery.
Yep.
In Australia, they sort of come and gone. There's a few other technologies that were seen to be the next big thing for sustainability, or for a safety aspect. But what along the journey, there's always been an issue of it's too high cost to manufacture.
Yeah.
It was too heavy to get to site. The life cycle wasn't quite there. The maintenance was too high.
Yep.
And so it all comes back to that, commercialisation. Can that technology be actually commercialised in an efficient and profitable business?
Yep.
And the lithium was one that sort of picked up, and as I said before, now you've seen there's hundreds of factories that are making it. Probably the next one we feel is a sodium ion, and that's we've been over to China and seen a lot of the lithium ion factories are now also spending a lot of money on developing sodium ion, and there's some benefits to lithium sodium ion versus lithium ion. One, lithium is quite a rare metal.
Yeah.
So that's
Mining for that.
correct. Yep, it's quite expensive as well.
Right.
It's a finite resource, and the sodium ion is seen as eventually a lower cost option. At the moment, it's not, and a safer option as well, and has some benefits that lithium ion doesn't have. So wider temperature range. So for negative, so lithium ion phosphate, for example, you shouldn't charge it below 0 degrees Celsius.
Okay.
Sodium ion doesn't have that limitation.
Okay.
It's a little heavier, so there's always pluses and minuses. But I think that's probably going to be the next one that we see more and more of.
Yeah, sure. Yeah, because you do see stories come out every so often about a new battery technology or new electrolyte that is proposed to dramatically increase battery safety and that sort of thing. So do you think a technology that improves safety alone will be seen as enough to be widely adopted, or it needs to have that?
I think there needs to be other benefits, and I think that's probably been shown even now. I mean, there'll be cheaper technologies available for e-scooter batteries. But they'll be heavier. They won't last as long. Slow recharge. So ultimately, the consumer will
Feel
demand.
the effects.
The demand will. The consumer will push the avenue in which ones take off, but they do need to be cost effective, and it does need to be profitable as well for the manufacturers. So that's one thing, and there needs to be some benefits for the consumer. Safety. It's an interesting one because at the moment they've seen as being perceived as being unsafe, and there are a few out there that probably are. But people still buy them. Yeah,
it must be tricky because as a whole, good quality batteries would be as a whole safe, and incidents would be very rare. It's just those few manufacturers or suppliers that might be doing the wrong thing or
cutting
corners that are kind of bringing the industry into disrepute to some degree.
Yeah. Look, and I think on that, sort of going back to that e-scooter side, they cop a battering as well. They're generally mounted on the bottom of the of scooters, so you're going up gutters, going over rocks. Lithium doesn't like to damage your cell in that way, and then go and charge it, especially with a charger that doesn't shut off. So I think there's a combination of factors. It's one of those things.
So what advice would you give to work health safety managers looking to improve their battery management overall and safety protocols?
Yeah, actually, and I don't mean to promote the Battery Industry Association again, but
Yep.
but they've recently put a document together for the safe storage of batteries, and that was lead acid and lithium-ion batteries as well. Again,
Excellent.
it was a question that had come up a lot, and the rules and regulations are very different in different states, even, and so it was seen as something that was required to put all into one document. Now, the document's big, and I know the guys are trying to get it to a summarised version that is useful, but all the information is in there. The challenge is there's no real, especially with lithium-ion, I don't know whether the requirements and the standards and the policing and enforcement of standards, it certainly hasn't caught up to the quantity of actually batteries being sold and stored. And so there's generally, looking through all of the documentation, there's very little specific requirements around safe storage of lithium batteries. And I think that's probably one of the challenges.
Sure.
But there is a document there. Again, you can go through and have a read of some specifics in your state and give you some ideas around what best practice. But that's probably...
Do you just want to talk briefly about the work that the Battery Industry Association does as a whole in general?
Yeah, so the Australian Battery Industry Association is there for the battery importers of new batteries. So the focus is generally on new batteries. There's the ABRI. They work very closely with ABRI. ABRI is the Recycling Industry Association, so they do the end of life. Australian Battery Industry Association look after sort of the start of life and generally the new batteries coming in and being sold and being transported and stored. And they offer that service to their members on the likes of, as I was saying before, sort of a best practice guide for your lithium-ion batteries, what to look out for. They've just facilitated the safe storage for batteries as a whole. There was also some labelling, so they did a whole piece on what to look out for and what are the minimum requirements for your labelling of lead-acid batteries as well. So those sorts of things to help our members, who are generally either the larger ones are manufacturers, but generally they're importers and resellers.
Yeah, great.
Does
that include safety data sheets as well? Is that part of the process?
Yeah, it does. Yep. So there are safety data sheets, and again, there's minimum requirements of safety data sheets. There's a global GHS requirement. So again, it's assisting the members on how to comply as best that they can.
Well, thank you very much for joining the Chemical Safety at Work podcast, Ryan. It's been a pleasure to have you here today. Thank you very much for our subscribers for listening in. We'll drop Ryan's details in the show notes below for anyone that's interested in learning a little bit more about Ryan, what he does, and the business as well.
Yep. Soon we'll be having Catherine Hull from the Association for the Battery Recycling Industry on the podcast as well, to be talking a little bit more about that end of battery life and how to deal with batteries after they've been used up or damaged or need to be disposed of. So, yeah, thanks again, Ryan, for joining us. Hope everyone finds that conversation really interesting. I know we did get a lot out of it. So, cheers.
Thank you.